Thank you so much, Penny. It's great to be with you CCL people. I was first introduced to CCL by my colleague Dennis Angove. Dennis and I teach an intensive short course on managing greenhouse gas emissions at the University of New South Wales every summer. And Dennis has mentioned CCL to me many times. So I'm speaking to you from the northern fringe of Sydney, a place called Barara Heights, and this is Guringai country. And there's a bit of background noise in my home right now, so I hope it doesn't come through. Okay, so my topic is basically a sustainable energy future for Australia and the world. And I'll now try and share my screen so that I can show the slideshow. So here goes. And now, can you see that, Penny?
All good, thanks.
All good? Fantastic. Okay, so there you are, there I am. And I've told Penny that I'll make the slideshow available to her and her colleagues in CCL for distribution after the presentation. Okay, so I'm going to start with a little bit on climate change and climate impacts before I focus on energy and in particular an ecologically sustainable energy future for Australia. So here we go. So first, you'll probably all be familiar with the impacts of human-induced climate change, starting on the top left, heat wave, going across clockwise, droughts, bleaching of the Great Barrier Reef, wildfires and floods. And what we're seeing now is that although Australia has always had heat waves, droughts, floods and bushfires, what we're seeing now is an increase in frequency and severity of all of these horrific impacts. Now, this slide shows Australia's greenhouse gas emissions from, now let me see, I'm going to have to move something here, from 1990 to 2016. And on the y-axis, we go up from 400 parts per million of CO2 equivalent, 400 million tonnes, 400 megatons of CO2 equivalent up to about over 600. And you'll see on this graph two different curves, one with blue squares and one with green circles. Now the green circles is the graph of emissions not counting land use emissions. That includes deforestation, reforestation, and similar impacts on the land. And the blue curve shows our greenhouse gas emissions over that period when we include the land use terms. And you can see they're very different. And in 1990, Australia succeeded in getting land use emissions included. And that made Australia's task a lot easier because, well, first because it's relatively easy to slow down deforestation, at least in theory, although it hasn't actually happened all over the country, but also because it's pretty hard to measure what the impact of land use is on our total greenhouse gas emissions. So you'll see that with the green curve, if we're just looking at all the emissions without land use, emissions increased pretty steadily from 1990 up to about 2009, and then leveled out. And then there was a drop from 2012 to 2014. And that drop was during the short period, the short 2-year period, when the ALP introduced a carbon price. And you can see quite a substantial drop in emissions. It's harder to see in the blue curve because of all the land use effects, but you can see a steepening of the reduction there. So just for fun, we've marked the periods when the ALP and the coalition were in government. And you can see that emissions increased generally much faster under the coalition government, but probably that's a bit unfair because most of the control, or much of the control over emissions, is a state matter, not just a federal matter. Anyway, so you've got those curves to think about. So I'm now going to just introduce another thought, which is what is a fair carbon budget for Australia? Now, you may be aware that there's only a certain amount of emissions that we can still emit on this planet before the temperature goes above 2 degrees or above 1.5 degrees. We've already increased the temperature by about 1 degree above pre-industrial levels. And scientists calculate that if we want to stay below a 2 degree average warming over the whole planet, then we can only afford to emit another 1,100 gigatons, that's billion tons of carbon dioxide before we've used up our remaining budget. And if we want to stay below 1.5 degrees Celsius, we can only emit another 340 gigatons. And to give you an idea, the annual global carbon dioxide emissions are about 37.5 gigatons. So you can see that we haven't got many years left globally if we want to meet the 1.5 degree target. We've got about 9 years left. Now, what about Australia's share? How do we calculate Australia's share? And actually, so I'm focusing on carbon dioxide because these are the emissions that are most accurately determined, although of course we know that other greenhouse gases also lift emissions further. So in 2017, Australia's CO2 emissions were 381 megatons per year. And if we include other greenhouse gases, that goes up to 530 megatons per year. Now I'll focus on carbon dioxide and we'll look at two rather different ways of calculating Australia's share. There's actually an infinite number of choices, and each of these choices is different in terms of ethics. So on the left-hand side, we have a choice called grandfathering, which simply says that we will take our current percentage of global CO2 emissions and apply that to us. So the global emissions budget is 340 gigatons. So 1% of that is 3.4 gigatons. So if we grandfather our emissions and we want to stay below, we want to do our share of keeping Australia below, we want to do our share of keeping the whole world below 1.5 degrees, then we have 9 years left at our current level of emission in Australia of 381 megatons per year. Only 9 years at the current level, and for the last 3 or 4 years, we have not significantly reduced our emissions. We're essentially emitting at the same level. So that's grandfathering, and that is actually a choice which is very, very helpful to those that want to keep emitting, because really Australia has to take into account that we are one of the biggest per capita emitters in the whole world. And so if we alternatively say that instead of, sorry, I'm going to go back again. So if we instead say that each person in Australia and everyone in the world is allocated the same amount of remaining emissions from the budget, that means we only get 0.33% of global CO2 emissions, which is 1.1 gigatons. And at our current rate of emitting, we only have 3 years left before we use up our share of the global budget. So you can see the equal emissions principle is, of course, an expression of fundamental human rights, that every person on the world should have equal rights, including equal rights to the remaining emissions. So that's something to think about. Okay, Now I'm going to move on to climate change and just talk a bit about bushfires, because we've been through a black summer. Well, actually, it isn't a black summer, it was a black spring and summer of bushfires. And the first severe bushfires actually started last July. So you could say it's really a winter, spring and summer of blackness in terms of bushfires. The blackness came afterwards. The bushfires were red and smoky. So how does climate change affect bushfires? Well, in two ways. Climate change leads to heat waves, and heat waves lead to drought, and so does climate change directly. And then once you've got heat wave and drought, you have dry fuel. And then all you need is a source of ignition of that fuel, and lightning is the main source of ignition of our horrendous bushfires, and then a strong wind behind it, and you have a firestorm. And as our fireys have told us, those firestorms, once they get going with a strong wind behind them, they're really unstoppable. Doesn't matter how many people you have on the ground, how many aircraft, you're lucky if you can even slow them down. Now I have to add that there are some natural phenomena that also increase the probability of bushfires, and these are called La Nina, which is a natural change, a natural variation in ocean temperatures in the Pacific, and the East Indian Dipole, which is another variation of temperatures in the Indian Ocean, and they also can help drive drought in Australia and contribute to bushfires. So we've been through that season, and sadly, that kind of season is going to come back again and again unless something is done to fight climate change. There's a whole range of other climate impacts that I'm not going to dwell on that you're aware of. The spread of what are called vector-borne diseases like malaria and dengue fever, which are spread by mosquitoes. We're seeing the drying up of major rivers like the Ganges, and in fact, all the rivers of Southeast Asia and South and East Asia arise in a plateau in Tibet and Qinghai in China, and the glaciers are melting, and after a rush of water, the rivers will dry up to a large degree. Flooding, on the bottom left is a picture from Collaroy in Sydney from storm surges to which climate change contributes by gradually lifting the sea level. On the right-hand side is a map of Bangladesh, where marked on the map you can see where the sea will get to with different levels of sea level rise, from 1 meter to 5 meters. 5 meters would cover half of Bangladesh, which has a population of 150 million people. Okay, and as you know, fossil fuel use, burning of fossil fuels is the main source of greenhouse gas emissions, which lead to climate change and global heating. And fossil fuel use also has other effects apart from its impact on climate. So we're talking about air pollution, land degradation, excessive use of water in washing coal and in coal-fired power stations. And in fact, there's a power station to the west of Sydney during drought times and otherwise uses quite a large amount of Sydney's drinking water. It takes water from the Cox's River, which flows into Warragamba Dam, our main drinking water storage. So, and then of course, electricity bills would be lower now if, or when renewable energy is installed. In the top right, you can see the lungs of a Los Angeles teenager who sadly died in a motor car accident. And this teenager was a non-smoker, and the black on the lungs is the result of air pollution, particularly from motor vehicles in Los Angeles. So getting rid of fossil fuel use is a good thing for climate mitigation and for fighting air pollution, water pollution, overuse of water, and respiratory diseases and land degradation and more. Fortunately, we now are in a position where we can choose. We have a choice of either sticking with the old fossil fuels or moving to an energy future based on renewable energy and the reduction of wasteful energy demand through efficient energy use, efficient energy generation, efficient energy conversion, and conservation of energy, which is changing our behavior. So we need to act on both the demand side and the supply side. And we're now in a situation where wind and solar power provide electricity more cheaply than new coal-fired power stations. Energy efficiency, many of those measures are very cheap as well. And so we are in a position where we can really act, and the main barriers are no longer technical, and they're no longer economic, but they are political. Okay, now, here is a pie for you, but unfortunately this is not a very tasty pie because it shows the distribution of Australia's greenhouse gas emissions over the year 2018. And it's showing the different sources. So up on the top, you can see electricity, which is 1/3 of our emissions. And then going clockwise, in the red, we have the fancy name stationary energy excluding electricity, which is basically non-electrical heating. Then transport. So electricity is 1/3, heating, non-electrical heating is 19%, transport is 19%, and coming around to what is called fugitive emissions. They're emissions of carbon dioxide and methane from oil fields and gas fields and coal mines and gas pipelines and so on. So all of those up to and including fugitive emissions are the result of our energy use from fossil fuels. And that part of the pie amounts to 82% of Australia's emissions. So if we solve the energy emissions, we can remove 82% of our emissions. It turns out that transforming electricity from fossil fuels to renewable energy is the cheapest and easiest way to go. And then some objectors will say, well, electricity is only 1/3 of our emissions. But the next stage is to electrify essentially all our heating. So we don't burn gas or oil or coal for heating, but we electrify the heating. And then we electrify our transport with electric vehicles, with better public transport, which is electric, and also, of course, human-based transport, better facilities for walking and cycling. So the first step is transforming electricity and then electrifying almost everything else. In terms of transport, the only areas that really are difficult to electrify directly are air and sea transport. And for those cases, we will need to use renewable electricity to produce a fuel that can be carried on aircraft in particular, but also on ships. So the way we do that is to use the electricity to split water into hydrogen and oxygen, and either use the hydrogen directly as a fuel or to convert it to ammonia by combining it with nitrogen from the atmosphere, because ammonia is easier to handle. So that's the situation with emissions. I won't try and talk about agricultural emissions because that's well outside my field of knowledge, but you can see that's 13%, that's quite significant. Okay, so based on this discussion, we have a strategy for basically removing all the energy emissions, which is most of our emissions. Of course, first we need to set targets, not just for 2050, which means nothing to politicians, but targets for every 5-year period up to, well, I would hope that by 2040, we have a zero emission energy system. We're already starting to replace fossil fuel electricity with renewable electricity. So that's listed as number 2, but a lot of these points can occur at the same time. We need to replace fossil fuels in heating with renewable electricity, with heat pumps especially, which are highly efficient. We need to replace petrol and diesel road vehicles with electric vehicles. We need to greatly increase the energy efficiency of our buildings and appliances. Now, on the way, we have to consider that a number of workers will be disadvantaged by this transition. So we need to assist workers to find other jobs, to be retrained, to be relocated, and if they can't be, to receive transitional funding to assist them through that process. But as you'll see, there are far more jobs available in renewable energy and indeed in energy efficiency than would be lost in fossil fuel use in Australia. And then we come to number 7, which is really deals with the remainder. Once we've got electric vehicles, we still need to produce a liquid or gaseous fuel for air and sea transport, and also a fuel for the chemical industry and for steel making, for converting iron ore to iron, and so on. And the pathway that's been proposed is to use renewable electricity to produce hydrogen and then possibly ammonia. And that could be an enormous export industry for Australia, because we have so much solar energy and actually a very large amount of wind energy as well. Now let's talk briefly about the job situation let's compare coal-fired electricity versus wind and solar electricity, because wind and solar are going to be the main technologies, the main sources of bulk electricity in Australia, and that bulk electricity will also provide transport and heating. So wind and solar are crucial. So going down the left-hand side, at present, the number of direct jobs in coal mining for coal power, either in Australia or overseas, are about 40,000. It varies between 30,000 and 50,000. So I'm just taking a middle figure of about 40,000 direct jobs. But actually, most of our coal is exported, as you know, 90% is exported. So the actual direct jobs in coal mining and coal burning in Australia to provide just our electricity, our coal-fired electricity in Australia, is only 4,000 to 6,000 jobs. It's not many jobs. When you consider on the right-hand side that the number of direct jobs in wind and solar right now, well, actually, these are old figures, is 13,000 already. So we already have far more jobs in wind and solar than in mining coal and burning coal for electricity. And coal burning is still nearly 60% of our electricity, while wind and solar are still only 12%. Now, I should say that more recent figures suggest that instead of 13,000 jobs, there may be already double that number of jobs in wind and solar in Australia. So there's a bit of debate about that. If we upgrade wind and solar to provide 80% of our electricity, and taking the conservative 13,000 at present, then we get 87,000 jobs. So there are clearly far more jobs in using renewable energy for electricity generation. Now I'm going to have to speed up a little, so I won't spend much time on energy efficiency, except to say that it saves energy and money, and there are many, many different technologies and measures that are highly cost effective, ranging from water efficient shower heads, ceiling fans, LED lights, induction cookers, bats, and so on. I'm going to skip across this graph, except to say that if you study it later, you'll see it shows the annual electricity use in Australia for different energy services, and say heating and cooling on the left, and then refrigeration, and then hot water as we move across the different bars. And the the blue bars represent an average of the current stock of technologies. The reddish bars are the best available now, and the grey bars are what is technically possible. So you can see huge potential for improving energy efficiency in heating and cooling, in hot water, in refrigeration, in lighting, and so on. It should also be mentioned that motor vehicles that are based on petrol or diesel are very inefficient in their use of energy, typically about 20% efficient, although it varies from about 15 to 30%, while electric vehicles convert about 85 to 90% of the electricity that they use into movement of the vehicle. So efficient energy use is very important, but because of time limitations, I'm going to focus on renewable energy. But first you need to know that when we burn, and I'm going to focus on electricity, and you need to know that when we burn fossil fuels, coal, oil and gas to produce electricity, most of the energy is lost at the power station as waste heat. So if we start with 100 units of energy on the left-hand side from burning coal, oil or gas, we convert it, burn that fuel, most of the energy is wasted, maybe 70% is wasted. We end up with only 30 units of electricity, or in Victoria, more like 25 or 20. And then we lose another 10% of what's left, another 3 units in transmitting that electricity to our homes and offices and industries. So the existing fossil fueled energy system is very inefficient. And if we look back the other way, if we save 1 unit of electricity by energy efficiency or by substituting renewable energy, effectively we save over 3 units of primary energy on the left-hand side. We save over 3 units of energy in coal, oil or gas. And of course, greenhouse gas emissions and air pollution mostly come from the left-hand side, from that primary energy end. So it really makes sense to both save electricity from fossil fuels and replace it with renewable energy. So coming to renewable energy, you can see Australia has a vast diversity of renewable energy sources. Starting on the top right, wind. We have big potential for hot rock geothermal, but it's not commercially available as we come down clockwise. We also have big potential for wave power, but that is still at what we would call the demonstration stage. We have hydroelectricity already, but because Australia is a dry country, we don't have much more potential for conventional hydro. But as you will see, we have huge potential for what we call pumped hydro. Then we have some potential for bioenergy, and the picture there shows a power station in Queensland which uses sugarcane residues and sawdust. And then we go up to solar photovoltaics, and then on the top left we have CST, which stands for concentrated solar thermal power with thermal storage. And that technology has thousands of mirrors reflecting sunlight onto the top of a tower in the center, making it very hot up there, and that heat can be used to boil water to produce steam to turn a turbine and generate electricity. And the strength of the CST system is that the energy can be stored very cheaply as heat overnight, and so you can have 24-hour power at least during the summer. But its disadvantage is that you need direct sunlight if you want all those mirrors to be able to focus sunshine on the tower. So you need areas that have lots of direct sunlight. CST doesn't really exist in Australia on a with significant power stations at all, but it does exist in Spain and in the United States. and in the Middle East. Now, along with renewable energy, as we increase the amount of renewable energy that varies, like wind and solar, we need to increase the amount of storage in the system. And I just want to say at this stage that there are two types of storage in a 100% renewable electricity system. The first type has the storage integrated with the renewable energy technology. So on the top left, you see a dam which stores energy. Basically, it's gravitational energy. In the middle, you see concentrated solar thermal with storage in tanks of molten salts. And on the right-hand side, you see a gas turbine, or otherwise known as a jet engine, and the energy stored is in the fuel tank. And what many people don't know is that gas turbines can burn renewable fuels as well as fossil fuels. They'll burn any fuel that is liquid or gaseous. On the second row, the lower row down, you can have storage that doesn't produce additional electricity. It's not a net generator. Batteries, the big battery in Adelaide, the Hornsdale Power Reserve on the bottom left, you see an example of off-river pumped hydro from Japan, where the lower reservoir is the ocean, the upper reservoir is on the top of the cliffs there. When you have excess renewable energy, the water is pumped from the bottom to the top. And when you have a shortage of renewable energy or high demand for electricity, the water is released, runs through pipes down to the bottom again and generates electricity on the way down. And on the bottom right, you can see an aerial picture of the Kidston mine in Queensland. This is a disused mine, and there is a project under development there for a off-river pumped hydro system where the mine shafts or the mine storages provide the reservoirs.